Alright, let's say you wanted to graph this problem that we just did above by factoring. Let's just change it. 4x squared minus 81. And if you factored it, it would be essentially the same. So let's put a y in front of it. Now you have a function. Y equals 2x plus 9, 2x minus 9, right? That's how you factored it. And we apply something called the zero product rule. Everyone say zero product rule? So you could put right here, this is called factoring. And now we're doing zero product rule. Write that down. That says you can turn any part of a factored function and you set it equal to 0. Subtract 9 divided by 2, and you get 9 halves, and over here you would get positive 9 halves. Raise your hand if you got that. Good? Class, are those my x or y intercepts? X. Those are my x-intercepts. Okay, so if you're graphing this now, using a straight edge, so if I want to use my graph paper, some of you have it, some of you don't, it's okay. 9 halves is 4.5, so between 4 and 5. The worst one is like students say 9 halves is a number between 2 and 9. It is, but if I say 2/3, some students will say, oh, 2/3 is between 2 and 3. It's like, I try not to say anything. So positive 4.5 and negative 4.5. Those are my x-intercepts. And then your y-intercept should be really easy. You just make, how to find your y-intercept, class? You're going to make your x equal to 0, 0 squared, and then that's 0, 0 times 4 is 0, so you have negative 81. So, not drawn scale. I guess I could have done by tens, right? 2, 4, negative 10, negative 20, negative 30, 40, 50, 60, 70, 80. I'll put it down here. You can if I zoom out. So 10, 20, 30, 40, 50, 60, 70, 80, a little bit past it. Maybe that one right there. Okay. And I have a function here. Class, what is this function? Parabola. It's quadratic. Oh, did you guys notice something? Ooh, someone said the word symmetrical. I like that word. For folded in half. Did you guys also recognize that this number here, odd or even? Notice its behavior and where it's pointing towards.